Assalamualaikum warahmatullahi wabarakatuh. Today my friend and I will present about the double heterostructure laser. First of all, what is double heterostructure? Double heterostructure is a fundamental and essential design for semiconductor lasers that can confine both electronic carriers and light within its cavity. Other than that, it compromises of light amplification layer and cladding layers, with the active layer sandwiched between two cladding layers with higher band gaps. Before that, we must know when the semiconductor laser were invented. They were invented in 1962, hence it's become an indispensable component for optical communication, optical displays, and other optoelectronic devices. In the figure below, it showed the 5 stages of development of the semiconductor laser. Today, the advancement of semiconductor heterostructure physics and technology have brought about significant improvement in our daily life. In many aspects of human society, heterostructure electronics are frequently employed. It's difficult to envision a world without DHS laser-based communication system, heterostructure-based light-emitting diodes, which is LEDs, heterostructure bipolar transistor, or low-noise high-electron mobility transistor for high-frequency applications such as satellite television. Nowadays, CD players come with double heterostructure lasers in almost every home. For both space and terrestrial application, heterostructure solar cell has been widely employed.
Hi, my name is SITI Najihah and MOHD 1170527. Today, I would like to present about the concept of double heterostructure laser. In double heterostructure laser, a low bandgap layer is placed between two high bandgap layers, gallium arsenide and aluminum arsenide. Two materials that are frequently utilized together. A heterostructure is a connection between two different bandgap materials, hence the name double heterostructure laser or DH laser. As you can see in this picture, figure 1 shows the double heterostructure device based on two junctions between different semiconductor material with different bandgap. Figure A is a double heterostructure diode, has two junctions which are between gallium arsenide and aluminum gallium arsenide. B is a simplified energy and diagram under a large forward bias. Resin recombination takes place in a P gallium arsenide layer. The third picture shows that the higher bandgap material have a lower refractive index. And the fourth picture is aluminum gallium arsenide layer provide lateral optical confinement. In optoelectronic device, the double heterostructure is a very useful structure with fascinating electrical properties. A PN structure is generated when one of the cladding layers is p-doped and the other cladding layer is n-doped, and the smaller energy gap semiconductor material is undoped. That's all from me. Thank you.
Okay, move to the next part, which is I would like to explain about the importance of double heterostructure laser. Okay, why we need a double heterostructure laser? First, double heterostructure laser model is simplified and idealized to illustrate qualitatively the effect of material and structural parameters on device behavior. Double heterostructure laser attracted a lot of attention as small, high efficiency, coherent light sources. Then it is also a useful tool, both understanding the effect seen in a real laser diode and predicting and perhaps optimizing the behavior of yet to be fabricated devices. Then it is also useful for correlating reported laser current threshold with device characteristic. Second, double heterostructure traps electron and holes effectively. We know that active region It is restricted to the middle layers thickness, lowering the threshold current density required for lacing. The excitant electron and hole are usually separated by an excitant Bohr radius. A greater number of electron-hole pairs can contribute to amplification, and fewer are left in the weakly amplifying parameter. In band gap engineering, heterostructure may be used to enhance efficiency by carrier confinement, while in refractive index engineering, it can be used to increase efficiency by photon confinement. And for the last one, the double heterostructure not only allows for better source radiation definition, but it also increases the optical power output per value.
So for the next part, applications of double heterostructure laser. There are three applications. The first one is optical storage system. Second one is space technology, and the third one optoelectronic integrated circuit (OEIC). For the optical storage system applications, the example is audio CD, which is audio compact disc. Audio compact disc make use of the index-guided laser device, which operates as a single mode in continuous wave operation with output stable towards time and temperature. Further development of optical storage system applications after audio CD are CD-ROM, which is compact disc read-only memory, and DVD, digital video disc. For the next one is the space technology applications. Space technology applications make use of gallium aluminium arsenide heterostructure solar cells, which is installed on satellites. One of the space stations, called Mir, has been using the technology for quite some years. The picture of Mir as in the image below. So for the last one is OEIC, which is optoelectronic integrated circuit applications, such as active matrix LCD, wristwatches, and automobile engines. OEIC applications uses photovoltaic thermal concept, where it make full use of high electron mobility in gallium arsenide to increase the speed of the electronic devices. Other applications of double heterostructure laser are highly efficient LEDs, semiconductor integrated optics based on distributed feedback DFB, and distributed Bragg reflector DBR semiconductor lasers, photonic signal transmission transistors, thyristors, and dynistors.
Lastly is the conclusion. In Al-Quran, Surah An-Nur ayat 35, Allah has stated that Allah is the light of the heaven and the earth. The example of His light is like a niche within is a lamp. The lamp is within glass, the glass as if it were apparently starlit from the oil of a blessed olive tree, neither of the east nor of the west, whose oil will almost glow even if untouched by fire. Light upon light, Allah guides to His light whom He wills, and Allah presents example of the people, and Allah is knowing of all things. In this ayah, there is a particular sentence which highlight His light is like a niche within which is a lamp. The lamp is within the glass. We can use this particular sentence as an analogy how the light propagate inside a fiber. The picture below is the description. The picture below illustrate the propagation of the light inside a fiber. Therefore, Allah inspire us to explore and investigate knowledge, which we are doing right now. I think that's all from us, and thank you for listening.